Right now, as we are very close to entering the new year, somewhere in the depths of space, a star the size of our entire solar system is tearing itself apart with the power of 10 octillion nuclear bombs. Don't you think this sounds powerful? But wait, you haven't seen the cosmic monsters yet that make dying stars look like shaking candles. Black holes that eat light itself, mysterious, unknown powers that tear apart the fabric of reality, and explosive events so violent they could erase our galaxy in seconds. Solar flares, controlled chaos. The surface of our sun just exploded. In the time it takes you to blink, yes, right now. A magnetic field line the size of Earth snapped like a rubber band and threw superheated plasma into space at 3 million kilometers per hour. This solar flare carries the energy of 10 billion nuclear warheads. Actually, our sun that seems balanced is a ball of controlled chaos that constantly builds up and releases magnetic tension. Deep inside, nuclear fusion creates a temperature of 15 million degrees, hot enough to pull electrons from atoms. This creates an electrically charged soup called plasma. The most powerful solar flare happened in 1859. Telegraph wires in Europe and North America sparked and caught fire. If such an explosion happened today, satellites would crash, electric grids would shut down, intercontinental internet cables would be cut. The estimated damage could reach $2 trillion, and repairing the infrastructure could take years. Supervolcanoes, the pressure cooker underground. Under Yellowstone National Park, a bubble of melted rock the size of Los Angeles is growing. This magma chamber is only 8 kilometers below the place where you are standing and contains enough superheated rock to bury all of the United States under 1 meter of volcanic ash. When this monster finally explodes, it will make every volcano in history look like a birthday candle. The explosion will be heard from 5,000 kilometers away, and the ash cloud will put the northern hemisphere into a volcanic winter that will last for years. The Yellowstone supervolcano has exploded 3 times in the last 2 million years. The most recent explosion, 640,000 years ago, threw out 1,000 cubic meters of rock and ash, enough material to bury the entire state of Texas under 60 centimeters of volcanic debris. The Lake Toba explosion in Indonesia, 74,000 years ago, brought humanity to the point of near extinction. The explosion threw so much ash and sulfur dioxide into the air that global temperatures dropped 12 degrees for several years. The human population may have fallen to just a few thousand people. Lightning, nature's sacred electric power. A single lightning flash carried more electric power than the city of New York uses in 15 minutes. That flash of light lasted only 2/10,000ths of a second, but it carried 5 billion joules of energy and reached a temperature of 28,000 degrees, 5 times hotter than the surface of the sun. Lightning forms when nature builds the world's most dangerous electric circuit. Inside storm clouds that rise 16 kilometers high, ice particles crash and transfer electrons like billions of small generators. The top of the cloud becomes positive, the bottom negative, and a 1 billion volt electric difference forms between sky and ground. Every second somewhere on Earth, lightning strikes the ground 100 times, 8 million lightning strikes per day. Each one carries enough energy to power a typical American home for 3 weeks. Nuclear weapons, breaking the atom. The most powerful nuclear weapon ever exploded broke windows from 500 kilometers away and was recorded as an earthquake around the world. The Soviet Union's Tsar bomb released energy equal to 57 million tons of TNT in a single explosion. The mushroom cloud was 64 kilometers high into the atmosphere. The fireball was 8 kilometers wide. Nuclear weapons work by releasing the basic forces that feed stars. In fission bombs, uranium or plutonium atoms break apart when hit by neutrons and release massive amounts of energy. This chain reaction happens faster than the time it takes you to blink. Fusion bombs take this concept even further. By combining hydrogen atoms under extreme pressure and temperature, they copy the process that feeds the sun. The energy needed to start fusion comes from a fission bomb used as a trigger and creates a temperature of 55 million degrees in an area the size of a baseball. The global nuclear arsenal contains enough weapons to destroy human civilization more than once. The combined explosive power of all nuclear weapons equals about 1.5 billion tons of TNT. Supernova, the death of stars. In the Orion constellation, a star 700 times bigger than our Sun is running out of time. Betelgeuse burns nuclear fuel so fast that compared to the Sun's 10 billion-year life, it will use up all its resources in just a few million years. When this red supergiant finally collapses, it will release more energy in 10 seconds than the Sun will produce in its entire lifetime. Giant stars die in the most violent explosions the universe can produce. For millions of years, nuclear fusion in the star's core creates outward pressure that balances the crushing inward force of gravity. The star burns hydrogen into helium, helium into carbon, carbon into oxygen. Iron becomes the star's death sentence. Unlike lighter elements, iron fusion absorbs energy instead of releasing it. When the core fills with iron, nuclear reactions stop instantly. Without outward pressure from fusion, gravity wins in less than 1 second. Even though the explosion contains more mass than all of Earth's mountain ranges, the neutron star shell is so hard that it can support magnetic field lines twisted into complex knots that store more energy than the sun produces in a year. Neutron stars, the densest objects in the universe. 32 kilometers in diameter, twice the weight of the sun, neutron stars are the densest objects we can observe in the universe. A single teaspoon of neutron star matter would weigh 6 billion tons on Earth, as much as 900 pyramids of Giza compressed to the size of a sugar cube. Neutron stars form when supernova explosions crush star cores beyond the breaking point of normal matter. The gravitational pressure becomes so intense that protons and electrons can no longer exist as separate particles. The atomic structure itself collapses. On the surface of a neutron star, gravity is 200 billion times stronger than Earth's gravity. If you could stand on the surface, you would weigh as much as Mount Everest, and your body would flatten thinner than paper in microseconds. Pulsars, cosmic lighthouses. Every 1.337 seconds, a cosmic lighthouse 28,000 light-years away sends a beam of radiation directly to Earth with the precision of an atomic clock. Pulsars are neutron stars that have become cosmic death rays. The fastest known pulsar spins 716 times per second, faster than a jet engine propeller. The surface moves at 24% of the speed of light and creates such extreme gravitational effects that it slows down time itself compared to our reference frame on Earth. Magnetars, magnetic monsters. The magnetic field around magnetar SGR 1806-20 is so powerful that it could erase every credit card on Earth from halfway to the moon. This neutron star has a magnetic field 1 quadrillion times stronger than Earth's. powerful enough to keep a frog floating in the air from 600 meters away by pushing against the water molecules in its body diamagnetically. On December 26, 2004, the star quake on SGR 1806-20 released more energy in 1/10 of a second than the Sun produces in 150,000 years. The gamma-ray burst was so intense that it temporarily blinded satellites, disrupted radio communication across Earth's entire daylight hemisphere, and measurably affected our planet's magnetic field from 50,000 light-years away. Neutron star collisions, cosmic bullets. Two neutron stars, each heavier than our Sun, are spiraling toward each other at half the speed of light. At the moment of collision, they create the most violent explosions since the Big Bang. The collision releases more energy than the Sun will produce in its entire 10-billion-year lifetime in just milliseconds. During the collision, rapid neutron capture processes create elements heavier than iron. A single neutron star collision produces gold, platinum, and other precious metals worth several Earth masses and throws them into space at 20% of the speed of light. Hypergiant stars are cosmic pressure cookers. If you placed the hypergiant star UY Scuti at the center of our solar system, its surface would reach beyond Jupiter's orbit. This star monster contains enough material to make 5 billion stars the size of the Sun. Hypergiants are so unstable that they experience false supernova explosions, powerful enough to temporarily overshadow entire galaxies. Enna Carinae went through such an explosion in 1843 and temporarily became the second brightest star in Earth's sky, even though it was 7,500 light-years away. Black holes, monsters that bend reality. At the center of our galaxy, a gravitational monster 4 million times more massive than our Sun is hiding and can pull you into a line of atoms as thin as dental floss. Sagittarius A*, our galactic black hole, bends space-time so violently that clocks run slower near the event horizon. Black holes form when matter becomes so dense that it opens a hole in the fabric of space-time. At the event horizon, time stops relative to outside observers. At the singularity, density becomes infinite, and the laws of physics we know stop working. Supermassive black holes, galactic anchors. The supermassive black hole in galaxy M87 is 6.5 billion times heavier than our Sun, and its event horizon is bigger than our entire solar system. This galactic monster controls the movement of stars across a region that stretches 65,000 light-years. The most massive known supermassive black hole, TON 618, is 66 billion times heavier than our Sun. If this monster took our place, its event horizon would reach far beyond Neptune's orbit, burying our entire solar system in eternal darkness. Quasars, cosmic lighthouses. Quasar 3C273 shines with the brightness of 4 trillion suns. Even though it is 2.5 billion light-years away, it can be easily seen with amateur telescopes. This cosmic lighthouse is fed by a supermassive black hole that consumes matter equal to 300 Earths every minute. The brightest known quasar, APM 08279 plus 5255, exceeds the Sun by 4 quadrillion times and is bright enough to light up planets around stars thousands of light-years away. Dark matter, the invisible skeleton. The dark matter halo surrounding our Milky Way galaxy extends more than 1 million light-years into space and weighs 10 times more than all the visible stars, gas, and dust. This invisible gravitational skeleton determines where stars can form and how fast galaxies spin. Dark matter interacts only through gravity, which makes it completely transparent to light, but it dominates the gravitational architecture that shapes everything we can see in the cosmic landscape. Cosmic voids are the great nothing. The Boody's void is 330 million light-years wide and contains almost no galaxies in a region large enough to hold 25,000 Milky Ways side by side. This cosmic desert is also called the Great Nothing. Our local void is 150 million light-years wide and sits at the edge of our local galaxy group. This is why we see relatively few bright galaxies in certain directions. Dark energy, the force that tears reality. Dark energy makes up 68% of everything that exists in the universe. But scientists have no idea what it actually is, or why it is tearing apart space with increasing violence. Dark energy has been speeding up the expansion of the universe for the last 5 billion years. Distant galaxy clusters are moving away from us faster today than they did billions of years ago. This shows that something is actively working against gravity on the largest scales. If dark energy continues to accelerate at its current rate, the universe faces a big rip scenario. The expansion finally becomes so violent that it tears apart galaxy clusters, then galaxies, then solar systems, and finally the atoms themselves. This cosmic doomsday could happen in 22 billion years. The Big Bang, the beginning of everything. 13.8 billion years ago, everything that would form the observable universe was inside a region smaller than a single proton and exploded with infinite energy density. This was not an explosion in space. It was the explosive creation of space itself, along with time, matter, energy, and all the physical laws that govern reality. In a fraction of the first second, the universe expanded from quantum scale to astronomical sizes, while cooling from infinite temperature to just billions of degrees. In the first second of the Big Bang, the universe went through nucleosynthesis, creating the lightest elements from free protons and neutrons in a cosmic nuclear reactor working at 10 billion degrees. This process created roughly 75% hydrogen and 25% helium. Cosmic inflation, faster than light expansion. In the first trillionth of a trillionth of a trillionth of a second after the Big Bang, the universe expanded by a factor of at least 10 to the power of 26, growing faster than light, and that instant increase gained more size than the 13.8 billion years that have passed since then. Cosmic inflation was driven by a hypothetical energy field called the inflaton. This field created a form of anti-gravity that pushed space apart with exponentially increasing violence. Somewhere in the universe, a true vacuum bubble might be expanding at the speed of light, erasing every atom, every law of physics, and the concept of existence itself as it grows. This hypothetical disaster is called vacuum decay. Vacuum decay begins with a quantum fluctuation that creates a small bubble of true vacuum somewhere in the universe. This bubble immediately begins expanding at the speed of light. Its border represents an unstoppable wall of destruction that vaporizes matter, energy, space, and time itself as it grows. Multiverse. Infinite realities. If the multiverse theory is true, there are infinite copies of you reading these words right now, along with infinite versions where every possible variation of history, physics, and reality happens at the same time across dimensions beyond human understanding. The multiverse naturally emerges from cosmic inflation. different regions of space stop inflating at different times and turn into separate pocket universes with potentially different physics. These cosmic powers remind us that we live in a universe much stranger and more violent than our daily experience suggests. The peaceful night sky hides a cosmic battlefield where matter and energy enter into conflicts so intense that they reshape space and time. Perhaps the ultimate power lies not in a single phenomenon, but in the principle that governs how reality produces infinite forms of existence, destruction, and creation throughout cosmic space and time. The universe seems like an engine to explore every possible way that matter, energy, space, and time can interact. Don't forget to like and subscribe to continue our discoveries together. Thank you for listening to me. Merry Christmas!